So, good evening, everyone. Today, as of 28th December, I have done a case study on ML models, and I call this ML model prophecy. I've done three different models: case study, regression, ARIMA, SARIMA, and profit. So, basically, let's dive into the today's advancements today. So, recently, the Queen introduces visual reasoning model, which is the first time model which separates from language and reasoning. Also Meta Fair releases the concept model, which is again separates reasoning from language models. And most open source books, because news for the today that advancement in the ML models is DeepSeek releases DeepSeek V3, which is a complete competition to the GPT 4.0 and Cloudy Sonnet 3.5. So this three models are the most advancement as of today, and this is a beginning, just beginning into the machine learning models, which helps the new technology and new boundaries to touch the sky in the industry of machine learning. So this data clean so this is the data clean is consistent, and it's 100% clean data. So as you can see, the data exploration includes the data exploration methods. Data exploration includes the data exploration. As you can see, there are no null values in this, and the data is clean as it is. You can see the data has all the data types integer, non null values, and there are 10 thousands of observation done in this data, and it starts from 1997 to 2024. So this data is completely clean, no null values, and as you can see, it is presented with the pandas data frame. Another part of exploration of data analysis is seeing for the zero values. As you can see, this data is so much perfect line by line. In the box plot, you can see the median is right in the place, and the whiskers are just right in the symmetric places. So there you can see there are no outliers. So this is pretty simple case study which has no outliers, and it reduces our next step that to eliminate outliers. If it is necessary, we will keep the outlier. If they are not necessary, we will eliminate the outlier. This is the third part of data exploration, and this gives us a solid visualization of date wise sales. How many sales have done? As you can see, the max sales have done over the 10 over the all the 25 years, or more than 25 years actually. It is 1994 to 2024. So which is again 30 years of these sales has not increased a bit. It has maintained a consistency of 500 sales per day. So this tells us a lot of information which we should know about this data, which we are not difficult to handle this data, because the consistency in us over the period is really same almost. And this introduces us to the date time variance, and the variance and the mean variance over the time, which shows us that this is stationary, is not stationary, and it is perfect for ARIMA model, because ARIMA model expects from the data that the data has retained its consistency over the time of period, and this visualization tells us that this data has really maintained its consistency over the time of period. Next, you can see the ARIMA PADRIMA stepwise summary. So this is a long leading step in ARIMA PADRIMA stepwise summary, which tells us about stepwise consistency over the time of period of the data. which again takes a time and gives us exact AIC number for the consistency. As you can see, the number will decrease over time, and it might increase, it might decrease, but it will eventually decrease over time as it completes all visualization with all the data analysis stepwise with uh, it's searching for minimize AIC, and as you can see, it is really doing its work. It will take around 3 minutes for entire data visualize entire stepwise. So we can just move along. This ARIMA PADRIMA prophecy has a projection. Prophecy is prediction. You can see this description. You can see the data preparation has done. Prepare the data set by handling missing values, outliers. We have seen no outliers and no missing values. The code selects the best ARIMA model using the auto ARIMA function, which we can see in the code implementation. Forecast generation. The selected model is used to forecast sales over the next 14 periods along with the confidence level. So confidence level is really important with the projection. It gives a model the output as a confidence level, which tells us the how the predicted exact each value is reliable to believe. Visualization, the historical sales data forecasted values, confidence intervals are plotted for visualization. So this is a confidence level. So this is ARIMA Patrima prophecy, which we can see that it has forecasted this. It has predicted that it might increase this year. So as you can see, it has maintained consistency. So it is usual if they try, if the sales can go easily up with little efforts. Accuracy assessments compare forecasted values with the actual values for the forecast period. So this model, this data is really consistent. This is really unique because there is no as such store I came across that do over the like for 30 years they just sell 500 or exact 500 or somewhere below 500 to 500, and they don't fall below zero also. So this data is really interesting. This company, this store can increase a lot to potential because it has maintained the sales in the market for a really long time. It shows that the store and the company has really maintained its consistency in the market, and they can easily scale up in the coming years with the advanced technologies. This is Prophet Prophecy. The Prophet is a model released by Facebook, and they call this Prophet because it really gives you the prophecy which you need to analyze the data. So this here forecast, you can see the dotted lines are nothing but the data points, the exact data points which we can see over the time. This is the exact sales which has happened, number of sales you can see. And forecast is the actual forecasted this data you can see the forecasted, which you can see clearly that this is really not correct that much because the data is so spread out, and the forecasted is just minimum with the y-axis, and it's surrounded by the data points, and which also says that this is really uncertain intervals. In the uncertain intervals you can see the data points falls. So this is the profit forecast. Then we can see here the day of the day year, and yearly you can see the trend has gone up. The curve tells you that this data the sales and the sales has happened over the time really big, and it has went down somewhere in November 1 and March 1, and it has maintained its consistency for like between March and November pretty much. And weekly analysis also tells you that the Wednesday being the lowest, and the sales are the lowest on the Wednesday and highly spike on the Sunday to Monday, and also from Thursday onwards it spikes. and data from 1998 to 2026, the projection it tells that, as you can see, from 2024 it has potential to grow up. It won't, as the data has said that the sales has been consistent for more than 30 years, so it easily can go spike, scale up the scale sales. With logistic regression and random forest ML machine learning model, we can clearly see that the projection which we in the orange, which is a predicted and actual, and the predicted and actual are pretty much different, which are usual in the logistic model, regression model, because it deals with linearity, and the data has no the has little non-linearity within it. So that's why we introduced random forest to predict and cover up for that non-linearity. To deal with the non-linearity, random forest is introduced. So as you can see, the regression analysis statistic method to understand relationship between variables, predict future values, and benefits, understanding relationships, predictive power, and flexibility. Random forest, an ensemble learning method for high accuracy, robustness, and feature importance. High accuracy, robustness to outliers, noise, insights into feature importance, capturing complex non-linear relationships. So this is really big. So machine learning models predictions versus actual. So this has different sections: over performance, percentage matrix, shows prediction accuracy relative to actual sales. Other difference matters. ARIMA struggles with complex patterns. As you know, the ARIMA expects the data to be the stationary, which not many times the data is stationary. I found this data which has stationary, so I wanted to apply ARIMA. So I found a data which has a stationary background in it, the stationary consistency variance over the time of period, the mean value deviations, all the stationaries over the time of period, and this puts ARIMA in the place to predict a model. So ARIMA struggles with the complexity patterns and multiple seasonality factors. Why the difference matters? Profit indels seasonality trends. As you have seen, the profit tells you the seasonality, season wise, the weekly wise, day wise, weekly wise, yearly wise, and monthly wise. It tells you the trend and automatically requires tuning. So it requires tuning. So as you have seen in the dotted scatter plot, which has predicted forecasted, it is really thin line within the y-axis equal y equals 0. It has really thin line, and it has predicted a lot different value than actual value. So this tells us that profit reads a fine tuning to require to before giving the final predictive value. Why does the difference matters again? Why difference matters this much? Because random forest benefits from manually engineered features and can learn from flexible patterns. It's a non-linear random forest deals with non-linearity, and it can actually engineer the features of non-flexible or more flexible patterns. So final insights: random forest prediction track actual sales more closely, relates resulting in small deviations. Small deviations means high precision. So if we have small deviation with the data is completely closely precise, you can trust and rely on and appropriate. Final insights on map provides a clear stakeholder friendly way to express forecast accuracy. COVIDs and next steps: data shifts over time may require retaining and recalibration. Caveats and next steps: again, combining profit, random forest, and prediction can sometimes improve forecast. Interpretability is crucial, considering profits interpretability or use of SHAP's value in random forest. So this is the ML predictions versus actual. Next, I go on residual plot. Is model reliable or appropriate? This residual actually tells us if the model is easy to trust or not. Residual errors are the errors should be random. If the errors are not random, if they gives a systematic, symmetric visualization of the model graph, then the model is not reliable to trust on. So here you can see that a residual plot has 0 to 200 and it goes below 300, and at the same time the moment it goes 200 above, it won't go a k minus 200, which tells us this is not symmetric visualization. And along the red line, y equals to, x-axis and y equals 0, it really finds a error which is random. So horizontal line at 0 helps to see if the results are centered around 0, which is really completely right. It is centered around 0. As you can see, the tens of the data is in the middle, which is around 0, and should be scattered randomly around the horizontal lines. You can see the randomness of the data, which is so fine. And then again, if present, it suggests that a model is not capturing sometime. If the pattern or trend is there, which we cannot see here, that the model is not appropriate or not capturing the data completely. If the if if the residual is really pattern and has a pattern overread, that the error has a pattern, then you can see that data has a erroric pattern in it, and data model is not capturing the data completely. If the residual error has no pattern within it and it's just completely random, you can see that there is no error in the model capturing the data. So spread of residual is really necessary to check. With this, I end my presentation for the case study which I have done for the forecasting. Any forecasting you can do with these three models and go with the residual plot to ensure that the model is capturing the data completely. Thank you.